Alright, hey everybody, welcome back. Today we're going to be looking at my procedural terrain generator, which is a 3D terrain generator that uses a height map underneath, but my main goal here was to be able to expand the world beyond the height map, or to as large of a height map as I wanted to, and then beyond, so I could get 16 by 16 kilometer terrains, or whatever I wanted to set it to. So as you can see, there is a mesh with the collider underneath my feet right now that is based on the height map, uses bicubic interpolation to read between the points on the height map, because the height map is only 256 by 256, and I could make that larger, but the idea here was to save memory on the height map and do all of the height calculation using math instead. So this is a very big world. Right now this is 8 kilometers by 8 kilometers, and it is on a quad tree. So one of my goals here was to be performant as you walk through the world. And as you can see, as I'm moving through here, and I'm moving through here faster than a player character normally would, you can see only just a tiny little hiccup when new chunks from that quad tree are loaded. That is on a multi-threaded piece of code, so it's very performant, which was my goal there. And it loads up the grass with lazy loading, so we can't see it because it happens too fast, but the grass is actually being loaded slowly over time. And the other thing that I wanted to do with this world, and you can see how I've already done it with the trees, was I wanted this to be a world where it was made up of data structures where I could add anything I wanted. So I could generate some kind of civilization on top of this world. I could have other data structures maybe laying on top of it around resources, influence. Obviously, things like Dwarf Fortress and its world generation are an inspiration to us all. And having something like that in 3D, even at the micro level, was what I was going for here. The other thing I wanted to have with this terrain was the retro aesthetic using modern rendering techniques. So you can see with the grass here, this grass is a very crudely drawn set of lines using a basic brush in Krita. And I'm using a wind shader to deform it, but they're basically just a bunch of cross billboards. I think, or not billboards, but cross quads. I think each set of grass has 16 triangles or something like that, 8 quads that are crossed to each other, and it's the same texture just repeated on all of those quads. And then the shader has the wind effect, and the shader also controls the the height and the scale and everything to do with the grass. So that plus the trees, where I have some you can kind of see the branches waving and the leaves rushing in there. It's a similar rendering technique where I actually use tree it to create these trees, and then the branches themselves are just textures. I just drew a little branch with some leaves, and I'm using the shader to deform them, and it's vertex colors on the model that were baked in by tree it to get the shader to know where the wind should be affecting the tree. So there's no bending and deformity on the base of the trunk, or the middle of the trunk for that matter, but as you go further up the tree and further onto the branches, there's more deforming. So these are the modern rendering techniques I'm talking about, but was still kind of that low-res texture. Even on the ground, you can see that's kind of a low-res texture. I want to keep that retro feel, partially because it's very easy to iterate on art. This grass took me 15 minutes to make. Those leaves, drawing the branches for this tree, not very long. Tree It is a great software if you haven't checked it out. Very easy to generate these trees. I'll generate 30 more iterations of them in 30 minutes, no problem. So that art style to me, even though it may not be the most beautiful, it's still pretty good. And I think games like Valheim have really shown what's possible with that low-res art style. And that was a big inspiration to me as well. So that's what I was trying to do with this terrain. I think the results have been a little mixed, though. As you can see, and I talked about a little bit, the performance is there, the size is there. I have all of these different biomes. I can introduce variety through different climates and generate different stuff on the terrain that way. And it's got the art style I'm going for. But this takes up a lot of memory. I mean, this right now, I think I'm using like 20 gigs of RAM just to have this terrain running on the server, and or not on the server, but on my PC, because the only way it's performant to load all of this data, all of these things that need to be loaded in every chunk as you're going across the world, and I kind of showed how there's just that little tiny blip. Yeah, there it is. You can kind of see there's a tiny little frame drop that happens. When that, if I don't have the entire world cached somewhere before that happens in some data structure, that blip will be way too long. I mean, it'll be longer than like those old Morrowind on the Xbox blips. And that's not something that I wanted. I didn't think that was going to be okay. So I was like, well, let's see if we can cache everything to make that work. And it works. But some people don't even have 20 spare gigs of RAM on their PCs to be able to use. So I think that that's not a great way to do this. And the reason that it had to be done that way partially is because of the LED system. So I went with a quadtree. And the quadtree has so many different levels to it, even though I think I only set it down to like 4 or 5 levels. Each one of these chunks has each space of chunk on this terrain has so many different versions that the cache just grows and grows and grows. Basically, it's exponentially to make the quadtree work. So if I was to do this again, I don't think I would do a quadtree. I think I would do regular chunks. Their regular chunks are ugly, right? Like you are having like these lower levels of details that are a little more obvious, but it lets me free up some RAM, and it doesn't require all that caching to be done. So I might go with a regular chunk stream instead of the quadtree. And then due to my goal around how I want to be able to place things on the ground here, as I mentioned before, this height map is not 1-to-1. Right now it's like 30-to-1 or whatever 8,000 to 256 is. Each blade of grass, or each spot of grass here, needs to be calculated at its position between sets of pixels, or between pixels on that height map. So doing that means that I have a whole bunch of data that I need to keep track of, like where all of these individual pieces of grass and these trees are, and the more data I want to put on top of that, like for roads and for buildings and points of interest, enemy spawn points, whatever you want to put on here, every time I do that, I'm gonna have to calculate and store a new position or a new data structure in that position. So this RAM problem is only going to continue to grow, and I think that's an obvious limitation of when you're trying to make big terrains in general. And there's probably a way that I haven't tried yet to do this so that more of that data is sitting on the hard disk. But that comes with its own challenges too, because then again we come back to the performance of having to load something off your hard disk every time that you come near it, and that not working with this quadtree system. So definitely with a more traditional chunking system, I think that there's a way that you can break that up a little better. But with the quadtree is so dynamic and has so many levels of detail it would be costly. Every frame would be a lot of checks to what's going on the hard disk, and I didn't want to go down that road, so I don't think I'm going to continue on that path. And then the other thing with that is, if I want to do any iterations on the height at the more granular level, like if I want a road or I want a building to flatten the terrain underneath of this, that needs to be done on the height map itself and then recalculated. And that we may not be granular enough. So, like I said, if we're on a 256 by 256 map right now, and the like I think between maybe 5-10 meters is each pixel or something like that. Whatever that ratio works out to be. I mean, like there'd be like a pixel here, and then a pixel here. If I wanted to place a building, or even just like a rock or an object, or even, like these trees, for example, and I wanted it to deform the terrain just around that little size, I would have to basically maintain a separate height map, which is basically what I'm doing now. Actually, I have to maintain the separate height map with this calculated high detail thing, and I've just lost all of the performance gains and memory gains I had from doing the quadtree in the first place by having that second height map. And it's one big mega height map, by the way. It's not like a chunked up one like they would use in a professional studio. So this is really limited in terms of what I wanted to do with that goal, and unfortunately I'm not going to be able to. I think in a way that can run on a normal person's computer as a game, I don't think I'm going to be able to do this. I think it's stuck. So I wanted to make this video to both walk you through the progress I made, because I am happy that I was able to accomplish this, but I also want to share some of those pitfalls and lessons learned, and I'll also walk you through the code here to show you some of the specifics about that, and maybe you can learn from what I've done. So this is my terrain generator class. It is almost 800 lines of code, including some commented out sloppy stuff. So again, this is all work in progress that I'm showing you. But I just wanted to walk through sort of how I did this. First is the quadtree. If you're not familiar with that, I unfortunately did not find a lot of great resources on how to write the quadtree. I copied somebody else's code partially. There's a great resource. I'll have to see if I can find it and link it down below, that someone made on like a really demo quadtree, subdividing a mesh and doing it that way. And I just kind of expanded that to my whole height map situation. But as you can see, I've got all these meshes, maps, in states being generated and initialized here, and then as the quadtree runs, what's going to happen is that we're going to go through every section, the smallest chunk size that you can have throughout the entire map. I'm going to generate a little cache there. And I needed to do this in order for this to be performant, like I said, and also to be able to reference this information to look at a subset, a smaller part of the terrain than what's shown on a height map. So this is where the big RAM chunk comes from. It is and this is done multi-threaded in C#. So even with that, it still takes a long time to run the game. I think it's like a 60-second world generation load time, which isn't bad when you think about things like Valheim and how long it takes to generate that world. But also Valheim's got all of their dungeons, all of their enemies, all their resources, and everything else going. So I think if I was to keep working with this, I don't think I would actually be able to hit a reasonable speed. So I'm generating the cache, and then for each quadtree chunk, the mesh needs to be generated. Again, I'm doing this asynchronously on multi-thread. And then they all have to have their own little caches where they're keeping track of all the noise maps that I'm using. So I'm using multiple noise maps to keep track of every single type of influence to be had on the terrain to create my biomes. So I'm keeping track of those there. And then I'm using a pretty standard vector calculation to create my triangles from there and apply this data. Some of this stuff is being applied directly into the shader. So the shader is reading these colors, so it knows what texture to apply. And then I have a texture array sitting on the shader, where that texture array is going to be looking at which colors I've assigned to it and picking what texture to blend to. So I know some folks are doing texture mapping where there's a splat map, but this one, I even though the blending is a little less attractive, I think. It allows me to have that texture array as long as I want. So I can have as many types of biomes and textures on there as I want, which I thought was necessary if I wanted to have roads and other types of terrain on there. I was going to eventually need to bloat the number of textures I could render. And then we do grass. This is grass multi-mesh because I didn't change the name yet. But one thing I want to talk about here is I'm going through every single sub position on the height map, or between the points on the height map, and queuing up whether or not there should be a blade of grass or a set of grass generated there. And then if the if we've calculated that there should be some grass at that point, I'm using the rendering server instead of multi-mesh. So I tried doing multi-meshes, and I know some folks out there have had good success with using multi-meshes, but I found I got roughly double the performance of a multi-mesh by switching to the rendering server. And the rendering server, the danger with the rendering server is your code is now the only thing that's keeping track of what you're rendering, versus typically the multi-mesh is keeping track of all its own instances. Now, whatever you wrote is keeping track of all the instances. And if you do that in the editor, like I do, because this is a tool script, so it's running in the editor. If you do that, every single grass instance can just get lost if you rebuild your code without clearing it out, or if your code state gets screwed up. You can just have a bunch of grass that's out there and you don't know what to do with it. So one trick I learned, and this is not the best way to do this, I bet, but one thing that I do is I have this thing called super clear. And in the super clear, what I'm doing is I'm actually telling the rendering server to get rid of everything. Destroy the whole world. If there's a whole bunch of grass that's out in your world that's being rendered, and I don't know where it is or what IDs that grass has, destroy it. Just destroy everything. We gotta restart. And this actually crashes Godot, but when you bring Godot back up, those grass instances are gone. So it works, and I'm okay with it. And it's one of those things where when I'll find some random grass that have popped up somewhere, it's like, oh, I guess I need to crash Godot now, and that's fine. And then there's this code about the LOD updates, which again, I know there's not a ton out there about this, and I don't even understand it super well. I just understand the basics of it. So what I'm doing in here is if we haven't generated, because remember I'm caching everything, if I have not generated this mesh previously, then start generating it. Otherwise, you should be able to load it straight out of RAM. And this might be an area where I could change that to disk, but again, that comes with its own performance cost as well. So, and actually creating the tri-mesh collision, not that expensive. This and setting things to visible, also not that expensive. So once you generated it's very fast. So there is actually an argument for, keeping a set of chunks in RAM that's smaller than the whole map, and then keeping the rest of it on your disk. And right now I'm keeping the whole thing in RAM, and that would require a whole other system to determine what are the sets of caches that I could keep in my RAM and not on my disk. And I wasn't willing to go down that road, knowing that I was about to have a whole bunch of other issues. Yeah, so that's that code. The other thing I want to call out is the way I do climates. This is a two-dimensional array that is using noise map values as a lookup. So I have a noise map that's basically the temperature, and a noise map that's the moisture, and all the biomes are set based on that. You could do it more complicated than this, and you could have like a sweeter biome system, but to me this is like a very easy and simple visual representation to select biomes, and it's a trick I learned from an article I read a while ago, and I really like it. And one thing I'll just note real quick too, the shaders that I have for the terrain and the trees and stuff, they're mostly for selecting textures on the shader, and on the trees and the grass, I mentioned it's that very simple texture that's being applied to every quad. If you don't know, transparency in Godot is very expensive on the GPU. So, because it requires multiple passes to render transparency. One thing that cuts down on that expense is if you use a technique called alpha scissor. And alpha scissor basically just says, instead of trying to calculate the transparency of everything, it just says if your alpha is above this value or below this value, just don't render anything there. It's a much cheaper way of doing it, and that's how I did it in my grass and trees. So I highly recommend trying that if you're having issues with your GPU performance with these shaders. Anyway, thanks for watching. Hope you enjoyed. Feel free to ask me any questions in the comments, and I'll try to help you out. Thanks, everybody. See you next time.